Welcome everyone to our review session. We have our exam tomorrow night and we want to make sure you're ready for it. So I'm going to do some problems that sort of hit most of the major topics that we've done this semester. And I really hope that you find it useful. And as I've said in my comment towards the side, if you have any questions, please ask them and I will make every effort to answer them if I can. All right, we're going to start with today is going to be a polynomial. And we're going to look at p of x is -2 times x minus 1 times x plus 2 squared. So our goal will be to graph this, but let's do some analysis of this first. Come on, autofocus, let's make that work. Thank you. So we know that this is to the first power and that's to the third power. So our overall this is order 3. And we know that we have a negative leading coefficient. So that gives us some idea of the shape. We know x cubed looks like this. Negative x cubed looks like this. So all odd powers behave that way. So if I have a leading term that is negative for an odd-powered polynomial, this is the shape that we're going to have, which means as x goes to negative infinity, p of x will go to positive infinity. As x goes to positive infinity, p of x goes to negative infinity. So that's one nice thing we can get from this order 3 odd power. Leading term negative has to behave that way. Now let's do some analysis of our zeros. So what are the zeros of this polynomial? Well, we have x minus 1 to the first. So x minus 1 has to equal 0. So x equals 1 is a 0 of order 1 or multiplicity 1. Over here we have x plus 2 squared. So x plus 2 has to be 0. So x will equal -2. But that has multiplicity 2. And how about we get a y-intercept? That would be the value of the function when x is 0. So what is p of 0? What do we get? We get -2 times 0 minus 1 times 0 plus 2 squared. So p of 0 is going to be -2 times -1 times +4, which I guess is going to be 8. So 0, 8 will be our y-intercept. Can we put all this together to make some kind of a reasonable graph for this? Well, let's take a look. We have a 0 at 1, multiplicity 1. We have a 0 at -2, multiplicity 2. We know this is our shape. And then my y-intercept way up here is 0, 8. So we know it's got to go up to the left, so it's coming up. This is multiplicity 2, so it will bounce, head up that way. Now, we're not really sure when it hits its maximum. It could be there. I'm not going to assume that, but then it's going to head down through 1. And that's a rough graph of what that will look like, a general idea. Again, the 0 at -2 was multiplicity 2, so that's going to bounce. The 0 at 1 is multiplicity 1, so that's going to go through the graph. That's the first question I want to look at. That's a polynomial, so you need to be able to graph polynomial given the function, or if I give you the graph, you've got to be able to create the function. We've done that many times during the course of the semester. Okay, the next example I'm going to do for you is going to be a rational function. So what we're going to say here is we're going to say r of x is 2 times x squared plus 2x minus 4 all over x squared minus x minus 6. We want to figure out what we can do with this. And the first thing I'm going to notice is we have the same order upstairs and downstairs. So if that's the case, we have a horizontal asymptote where, which is the ratio of the highest powers. 2x squared upstairs, 1x squared downstairs. So I know I'm going to get a horizontal asymptote. 2x squared divided by x squared is 2 at y equals 2. Now to get the vertical asymptotes, I'm going to need to do some analysis. So let's go ahead and factor as best we can. So you'll notice I have a 2 everywhere upstairs. Let's factor out the 2. X squared plus x minus 2. And downstairs I have x squared minus x minus 6. Can those factor? I think so. How about 2 times x plus 2 times x minus 1? And downstairs I will have x minus 3 times x plus 2. And at this point you will notice that we have an x plus 2 upstairs and downstairs. X plus 2 upstairs, x plus 2 downstairs. Now negative 2 is not in the domain because that makes the denominator 0. X plus 2 is 0. When x equals negative 2, the function is not defined. Since it cancels out, we have a hole at x equals negative 2. But what else do we notice? X minus 3 downstairs is also not in the domain, but that is going to be an asymptote. So when does x minus 3 equal 0? When x equals 3. So we'll have a vertical asymptote at x equals 3. And how about an x-intercept? How about an x-intercept for this problem? Well, when do we get 0 here? Well, 2 is never 0, but how about when is x minus 1 equal to 0? X minus 1 is equal to 0 when x equals 1. So my x-intercept will be at 1, 0. So there's a lot of things going on here. Let's see if we can construct some sort of a reasonable graph for this. So what do we have? Asymptote where? Asymptote at x equals 3, asymptote at y equals 2. Probably a good place for us to start. X equals 3, 1, 2, 3. Vertical asymptote at x equals 3. Horizontal asymptote at y equals 2, 1, 2. Now we know we have a hole at x equals negative 2, but for the sake of discussion, right now we're saying that r of x is essentially 2 times x minus 1 over x minus 3. Now we know negative 2 is not really in the domain. But if I plug negative 2 into that domain, what do I get? What do I plug it into the function? If negative 2 were in there, what would the y value be? 2 times negative 2 minus 1 over negative 2 minus 3. This looks like 2 times negative 3, negative 6 over negative 5, or 6/5. So at negative 2, I have a hole at 6/5, or at 1.2. Here's negative 2, 6/5, a little bit more than 1. We'll put a hole there. Where is our x-intercept? Our x-intercept is at 1, 0. How about our y-intercept? What would our y-intercept be? Let's go ahead and find out what r of 0 would be. So again, here's our r of x, 2 times x minus 1 over x minus 3. How about r of 0? 2 times 0 minus 1 over 0 minus 3. Negative 2 over negative 3, 2/3. So 0, 2/3 is our y-intercept. Y-intercept is 0, 2/3, which is here. And then we know this is an asymptote, so I bet you have an idea how this graph is going to go. And then it comes down gradually like this. We don't have a whole lot of information on the other side of the graph, but keep in mind, this is an asymptote of order 1, x minus 3 to the first power. So if that's the case, they're going on opposite sides. That's going to negative infinity. So this one has to be going to positive infinity. And the general shape of that looks like this. If you want more detail, you could plug in some numbers like 3, 4, and 5. But for the most part, this gives us a reasonable graph for what we're looking for. for that original polynomial, which was 2x squared plus 2x minus 4 over x squared minus x minus 6. All right. Next, we're going to go ahead and solve some equations. What I will do next is e to the 2x equals 3 to the x plus 1. The tool that we want to use here is the logarithm. Ryan asks, why was the ha 2? Let's reinforce that one more time before I go on. Why was the ha 2? Remember, give me the asymptotes in equation form. So notice x squared upstairs, x squared downstairs. Highest power is the same top and bottom. So all we have to do is look at the ratio of the highest terms. This coefficient is 2, that one is 1. 2 divided by 1 is 2. Hence, the horizontal asymptote is y equals 2. Hope that helps. Okay, moving on to our next question. E to the 2x equals 3 to the x plus 1. Let's hit both sides of the natural log. Natural log e to the 2x equals natural log 3 to the x plus 1. Then we're going to pull the exponents down front. 2x comes down. X plus 1 comes down. Then we're going to say 2x times the natural log of e equals x plus 1 times the natural log of 3. I'd like that to focus. Doesn't like the light that's showing up here. Don't forget the parentheses. That's important. Natural log of e is 1. So I get 2x is multiplied out, x natural log 3 plus 1 natural log 3. Let's get all of the x's on one side. So we're going to subtract x log 3 from both sides. 2x minus x natural log 3 equals 1 times natural log 3. Factor out the x again. We get x times 2 minus natural log 3 equals natural log 3. And then we'll divide both sides by what's multiplying x? 2 minus natural log 3. And we get x is natural log 3 over 2 minus natural log 3. So that's that problem. The next one that I will do is in the world of logarithms. So I want to solve log base 3 of x squared minus 8x equals 2. Before I spend much time on logs, let me remind you that you cannot take a log of a negative number. You cannot take a log of 0. So whenever you do these, you have to go back and check your work to make sure that your answers are in the domain. The base of this is 3. 3 to the second power equals x squared minus 8x. 3 to the second power is 9 equals x squared minus 8x. Subtract 9 from both sides. 0 is x squared minus 8x minus 9. So let's factor. 0 is x minus 9 times x plus 1. So if that's the case, either x minus 9 is 0 or x plus 1 is 0. Adding 9 to both sides, x is 9. Subtracting 1 from both sides, or x is negative 1. Does 9 work in the original? 9 squared is 81. Minus 8 times 9 is 72. 81 minus 72 is 9, so that's okay. Does negative 1 work? Negative 1 squared is positive 1. Negative 8 times negative 1 is positive 8. 1 plus 8 is 9. That is also okay. So we have two answers to this log question. Both 9 and negative 1 are solutions for me. Is that the case with the next one that I'm going to do? So what I want to do now is log base 2 of x plus 7 plus log base 2 of x plus 8 equals 1. Now, again, remember that you cannot take a log of a negative number. You cannot take a log of 0. So let's make sure that our answer will be within the domain of the function before we finish. So the first, you can't see that? Now you can. So the first thing to recognize is that the log of the sum is the sum of the product. So log 2 of this plus log 2 of that is log 2 of the product, x plus 7 times x plus 8 equals 1. We can multiply all that out, and we can say log base 2 of x squared, 7x and 8x is 15x plus 56 is 1. Now, what do we do next? We think of the base of our logarithm. The base of our logarithm is 2. 2 to the first power equals all of this. 2 to the first power is x squared plus 15x plus 56. 2 to the first power is just 2. Let's subtract 2 from both sides. We get 0 is x squared plus 15x plus 54. Let's factor, that is x plus 9 times x plus 6. So either x plus 9 is 0, or x plus 6 is 0. Now, if x plus 9 is 0, what does that make x? X is negative 9. Or if x plus 6 is 0, x is negative 6. But if I plug those in, negative 9 plus 7 is negative 2. Not allowed. Negative 6 plus 7 is 1. Negative 6 plus 8 is 2. Those are both positive when I plug in negative 6. Therefore, my only answer for this question is negative 6. Negative 6 is all we get for that problem. Okay, moving away from the logs, let's go back into the world of trigonometry. And we're going to take some basic values. Before I do that, as always, let me remind you to go ahead and build your table. So as you do this, it's very important for you to make sure that you have a table of values that you can work off of. So what are the tables that I want? Values that I want in my table? 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We're going to start with that for degrees. Then we're going to go to radians. 0, pi over 6, pi over 4, pi over 3, pi over 2. Sine of 0 is 0. Sine of pi over 6 is a half. Sine of pi over 4 is either 1 over root 2 or root 2 over 2. Sine of pi over 3 is root 3 over 2. Sine of pi over 2 is 1. To get cosine, we just go backwards, right? We start at 1, then go to root 3 over 2, then go to root 2 over 2, then go to 1/2, then go to 0. So you'll notice this way forwards, this way backwards. And then we finish this up with tangent. Of course, tangent is sine divided by cosine. 0 divided by 1 is 0. This divided by this is 1 over root 3. This divided by this, they're the same as 1. This divided by this is root 3. 1 divided by 0 is undefined. So make sure you have that table to make this work as we're doing our problems. So we're going to start with that table, and then we're going to do some values, keeping in mind that in the various quadrants, the signs, S-I-G-N's, change for our trig functions. So the first question I have here is sine of negative pi over 3. So let's visualize that. Where is negative pi over 3? Negative pi over 3 is in quadrant 4. In quadrant 4, sine is negative. But the reference angle is pi over 3. So what we could say is, we could say sine of negative pi over 3 is negative, because that's in quadrant 4, negative sine of pi over 3, which of course is negative square root of 3 over 2. The next question I have for you, so we'll keep our table handy. Make sure you know those values. Next question I have for you is secant of negative 23 pi over 6. So what I have to do is I have to figure out what negative 23 pi over 6 is in my first revolution. So let's add 2 pi. Negative 23 pi over 6 plus 2 pi over 1 is negative 23 pi plus 12 pi over 6, which is negative 11 pi over 6. Well, again, let's add another 2 pi. So now I have negative 11 pi over 6 plus 2 pi is negative 11 pi, crisscross this way, plus 12 pi over 6, which equals pi over 6. Very good. That's something that I can use. So I have secant of negative 23 pi over 6 is the same thing as secant of pi over 6 using coterminal angles, which is 1 over, secant is 1 over the cos of pi over 6. Cos of pi over 6 is root 3 over 2. 1 over root 3 over 2. So we'll finish this off with what? With 2 over root 3, which you could rationalize the denominator, but I am not going to require that you do that on your exam. I apologize for the shadows. Let's go ahead and do one more in that realm. What I'm going to do next is cotangent of negative 5 pi over 4. Cotangent negative 5 pi over 4. Again, let's add 2 pi to get us a value that we can use. Negative 5 pi over 4 plus 2 pi. Negative 5 pi times 1. Negative 5 pi plus 2 pi times 4 is 8 pi over 4, which is 3 pi over 4. So I get cotangent of negative 5 pi over 4 is the same as cotangent 3 pi over 4. Well, what do we know about cotangent of 3 pi over 4? That's cosine of 3 pi over 4 divided by the sine of 3 pi over 4. Second quadrant, right? Second quadrant, cosine is negative and sine is positive, but the values are the same because the reference angle is 45 degrees. So negative root 2 over 2, positive root 2 over 2. After all that, my answer is negative 1. Negative 1 for that one. All right. Hopefully you're with me with most of these. We're going to move on in our world of trigonometry. And let's see how this one will go. So I'm going to say, let's get my paper aligned properly if I can. I'm going to say sine of theta is negative 3/5. So we know sine is negative in quadrant 3 and quadrant 4. But I'm going to say cosine of theta is greater than 0. So if sine is negative and cosine is positive, that puts me down here in quadrant 4. So let's kind of keep that in mind. I would like to find out what cosine is. So we know cosine is positive. Let's use our Pythagorean identity. Cos squared theta plus sine squared theta is 1. Cos squared theta plus negative 3/5 squared is 1. Cos squared theta plus negative negative positive 3 squared is 9. 25th is 1. So cos squared theta is 1 minus 9 25ths, 25 minus 9, which is 16 25ths. Now again, I told you cosine theta is positive, so I don't need to worry about plus or minus. So cos theta is the square root of 16 25ths, which is again positive 4/5. So we get that one, which is nice. And then we can also figure out a couple other things. If I ask you for tangent theta, of course, is sine theta divided by cosine theta. Sine theta, we said, was -3/5 divided by cosine theta, which is 4/5. And we get -3/4 for tangent theta for this problem. And let's also take a look at sine of 2 theta. So we have all this information. We know what sine is. We know what cosine is. So this time I want to take a look at sine of 2 theta. We need the identity. Sine of 2 theta is 2 sine theta cos theta. So the sine of 2 theta is 2 sine theta. We said was -3/5. Cos theta we said was 4/5. So what does that make sine 2 theta? -6 times 4, -24/25. And of course, there's a whole lot more we could do. I could ask you secant, cosecant, cotangent, anything like that to enable us to solve that problem, to do more analysis. But that's a pretty good start, I would say. Okay, we are going to take a look at a catapult that is hurling things. So here's the catapult. The arm is 20 feet long. When released, it's going to come to this position and it's going to unload. So it is going to go through this distance. How long does it take to do it? It takes 1/4 of a second. So 0.25 seconds before release. So you know what we want in this kind of a situation? We're looking for the angular speed and the linear speed. The linear speed is how many feet per second the payload is going to be hurled. But let's first find the angular speed. And let me remind you that angular speed is radians per minute, radians per second, radians per hour, whatever your unit of measure is. So in our case, our angular speed will be in radians per second. So we see it's going from horizontal to vertical, so that's a total of 90 degrees, or if you like, pi over 2 radians. So how long does it take? We have pi over 2 radians in how many seconds? In 1/4 of a second. So it's pi over 2 divided by 1/4. It's pi over 2 times 4 over 1, which is 2 pi. So my angular speed is 2 pi radians per second. Now, linear speed is actually going to be relatively nice here because we're going to convert from radians per second to feet per second. But what you need to recognize is what would 1 revolution be? So if we think of a circle, poorly drawn as always. If we think of a circle that has a diameter of 20 feet, what is the circumference? Excuse me, radius of 20 feet. Circumference is 2 pi times the radius. So in this case, my circumference is 2 pi times 20 feet. So the circumference is 40 pi feet. But if you're spinning something around, that's how many feet you get per 2 pi radians. So if we're looking at this, we are starting with this 2 pi radians per second. That was our angular speed. Times per 2 pi radians, per 1 complete revolution, how far does this thing travel? It travels 1 circumference. It's 1 circumference per 2 pi radians. So that's 40 pi feet per 2 pi radians. Well, you notice everything cancels nicely, and my answer is 40 pi feet per second. So I encourage you for the angular speed, linear speed problems to think of it that way rather than trying to memorize a formula. I think memorizing a formula is going to cause problems in the long run. Okay, our next problems, we're going to take a look at inverse trig. So the first one I have here for you is the inverse sine of -1/2. So the way I do this, I always say equals theta. So if that's the case, -1/2 equals the sine of theta. My reference angle, which we could get from that other page, my reference angle is 30 degrees or pi/6, and we're kind of required to use radians here for the inverse trig. But what is the range of inverse sine? That's what we need to know. Range of inverse sine is -pi/2 to pi/2. So I need sine to be negative. So what will my answer be? It's got to be in the negative first quadrant, which will give me a value of what? Will give me a value that theta is -pi/6. So the range of arcsine and the range of arctan is essentially the same, but arc cosine, inverse cosine, is different. So the next question I have for you is the inverse cosine of -1/√2 is going to equal theta. Again, I always like to write equals theta in to help me make sense of this. So -1/√2 is cosine theta. Reference angle will be pi/4. But what is the range of inverse cosine? That's what we need to think about. The range of inverse cosine is 0 to pi. So back for inverse sine, from -pi/2 to pi/2. For inverse cosine, from 0 to pi, which for a negative number will put me in quadrant 2. So my reference angle is pi/4, so theta will be pi minus pi/4. 4 pi minus 1 pi. 3 pi/4 will be my value for the inverse cosine of -1/√2. Okay, we want to move to some graphing. So I will take a look at the following. I want to graph y equals 4 sine 3x plus 2. So let's do our analysis quickly here. Our midline, it shifted up 2. So our midline is going to be y equals 2. Our amplitude is going to be 4. Now, how about this 3? Sometimes that's called omega. Little omega is 3. That's our multiplier. Well, that tells me I have 3 cycles in 2 pi. So if I divide by 3, I have 3/3 cycles in 2 pi/3. So 1 cycle in 2 pi/3. That's my period. Period equals 2 pi/3. So I'm going to put all that together to get us some kind of a graph for sine. So let's take a look. I don't know how much of this paper we'll be able to see. So starting with an amplitude of y equals 2, I'm upside down. An amplitude, excuse me, a midline of y equals 2. So I like to go ahead and put in a dotted version of the midline. So the midline is y equals 2, and we'll try to get this to focus. Here's our midline. Our amplitude was 4. So if our amplitude is 4, we have to go up 4. 1, 2, 3, 4. We've got to go down 4. 1, 2, 3, 4 from the midline. So my graph will be contained between these two lines. Now, we said the cycle was 2 pi/3. So starting at 0, there was no horizontal shift, no phase shift. My first period is going to be in 2 pi/3. Adding another 2 pi/3 will take me to 4 pi/3. And another 2 pi/3 gives me to 6 pi/3 or 2 pi. So you'll notice there's my 3 cycles in 2 pi that we talked about. Now, our graph is sine. Our graph is sine. How do we make use of that? Make use of sine. Let's think about the unit circle. Okay. So we're dealing with 4 sine 3x plus 2. Which you can see now. So our graph is sine. Let's consider the unit circle. Starts here at 1, 0. So the sine starts at 0. It goes here to 0, 1. Then the sine becomes 1. Over here, negative 1, 0. Sine's back to 0. 0, negative 1. Sine is negative 1. And then sine is back to 0. So we know sine is the y values on the unit circle. Start, first quarter, middle, third quarter, end. So it starts. So for sine, it starts at 0, goes to 1, 0, negative 1, 0. But we want 4 sine. If we're negative 4 sine, it's flipped upside down. We want 4 times sine. 4 times 0 is 0. 1 times 4 is 4. 0 times 4 is 0. Negative 1 times 4 is negative 4 and 0. So measured from the midline. My first period, my first window is here. It starts at 0. It ends at 0. The middle point is 0. The quarter point jumps up to 4 points from the midline. 1, 2, 3, 4 up here. 4 points from the midline down there. Here is our first period of that graph. Let's continue. Begins at 0, ends at 0. Midpoint is at 0. Quarter point up at 4. Quarter point down to negative 4. And we have one more. Begins at 0, ends at 0. Middle is 0. Quarter point up at 4. Down at negative 4 off the midline. So there's our graph for y equals 4 sine 3x plus 2. But you also need to be ready to construct a function if I give you the graph. So let's take a look at one of those. So what is this? What is this crazy thing? Well, wherever there's an asymptote, its reciprocal function is 0. 0 here, 0 here, 0 here, 0 here, 0 here. So maybe you can start to see what that reciprocal function would look like. So just looking at that part, that looks like cosine. Starts at 1, 0, negative 1, 0, 1. So that's cosine, but it's got a period of pi, not of 2 pi. So I have 2 cycles. I've got 2 cycles and 2 pi. So my first guess for the reciprocal function is that f of x is what? Is cosine of 2x. Except, of course, what's our amplitude? Up to 3, down to negative 3. So it looks like this graph I've drawn in purple is 3 cos 2x. And we can continue the process, by the way. Right? Continue it now. We can see our second cycle. So between 0 and 2 pi, you see 2 cycles, but you can see that we want the reciprocal function. So what is the reciprocal function? Will my answer be? So if this is g of x, is the graph that we see here in color, other than purple, g of x will be what? Will be the reciprocal of cos 2x. It will be 3 secant 2x, right? So given a graph like that, draw its reciprocal function and try to find the analysis that you need to get what you are looking for. All right. Let's go ahead and do a type of problem we've done several times. Solving a trig equation like cos 4 theta minus cos 2 theta is 0. And we're going to look for all solutions here. We want all solutions. To do that, we are going to need to have what? Make sure you can see it. We're going to need to have our formula to help us do that. I will give you a formula sheet on your exam. Cos A minus cos B equals negative 2 sine A plus B over 2 times sine A minus B over 2. So we want cos 4 theta. So wherever you see an A, you're going to put a 4 theta. Minus cos 2 theta. Wherever you see a B, you're going to put a 2 theta. Will be negative 2 sine 4 theta plus 2 theta over 2. Sine 4 theta minus 2 theta over 2. So we get cos 4 theta minus cos 2 theta is negative 2 sine what? 4 theta plus 2 theta, 6 theta over 2. 4 theta minus 2 theta, 2 theta over 2. So we have cos 4 theta minus cos 2 theta is negative 2 sine 3 theta sine theta. That was all of our analysis. Now, the original question was, that's going to be a problem if I show the light. The original problem was cos 4 theta minus cos 2 theta is 0. If that's the case, we will take negative 2 sine 3 theta sine theta is 0, which now requires me to solve two equations. Negative 2 cannot be 0, so I need to solve sine 3 theta is 0 or sine theta is 0. Well, sine theta is 0. We keep in mind our unit circle. Sine is 0 when the y values are 0. That's here and here. So it'll give me pi and 0. So theta is 0 plus 2 pi k. Theta is pi plus 2 pi k. If you want to be slick, you could say that's just 0 plus pi k. That's certainly correct. Over on this side, let me go ahead and introduce a variable. I will say let w equal 3 theta. Now I have sine w is 0. If w is 0, I get w is 0 plus 2 pi k, or w is pi plus 2 pi k. Remember, w is 3 theta. So we'll say 3 theta, 0 plus 2 pi k is just 2 pi k, or 3 theta is pi plus 2 pi k. Multiply both sides by a third. What do I get? I get theta is 2 pi k over 3, or over on this side, theta is pi over 3 plus 2 pi k over 3. So what are all my answers? I have 4 of them. We have 2 pi k over 3, comma, pi over 3, plus 2 pi k over 3, comma, 0 plus 2 pi k, which is just 2 pi k, pi plus 2 pi k. And remember, k is any integer, and I'll move my hands so you can see that final solution. Let's see where that goes. So, I mean, that's kind of a challenging question, but hopefully you're able to follow it. It's one we like to use often, so make sure you're prepared for it. All right. Next, let's take a look at a question that helps us remember how sine and cosine are defined. So if I'm going to say sine of 20 degrees minus cosine of 70 degrees, cosine means sine of the complement. So the complement of 70 is 20. So the cosine of 70 degrees is the same as the sine of 90 minus 70, which is the sine of 20 degrees. So making that substitution, if cosine 70 is sine 20, this becomes sine 20 degrees minus sine 20 degrees, which equals what? Which equals 0. So that's not so bad. Next, let's go ahead and prove an identity. Let me remind you of that process. How do we prove an identity? I want to prove tan theta plus cotan theta equals sec theta cosec theta. So let's take a look at that process. I always start with the left-hand side. So I'm going to say left-hand side equals tan theta plus cotan theta. And when in doubt, convert things to sines and cosines. Tangent theta is sine theta over cos theta plus cotangent theta is cos theta over sine theta. Now, sine times sine, sine squared theta, plus cos times cos, cos squared theta, over cos theta times sine theta. And I hope you recognize that sine squared theta plus cos squared theta is 1. So we get 1 over cos theta sine theta, which equals 1 over cos theta times 1 over sine theta. 1 over cos theta is sec theta. 1 over sine theta is cosec theta. And that is my right-hand side, and we are finished. That's that proof. And I have another proof for us to do here. Let's take a look at that one. The next proof I want to do for you is to prove cosine theta plus pi over 2 is minus sine theta. So to do this, I need to remember my identity, which I will give you. Cos of A plus B is cos A cos B minus sine A sine B. So I want cosine of theta plus pi over 2 is cos theta, cos pi over 2 minus sine theta, sine pi over 2. So, of course, that first was left-hand side. Then what do we get? We get cos of theta, cos of pi over 2. Let's look at our unit circle. Pi over 2 is here, which is 0, 1. So cosine is 0, sine is 1. Cos theta times 0 minus sine theta times 1. 0 minus sine theta, which is negative sine theta, which equals the right-hand side. So that's done. Let's take a quick look at a triangle question. So we have law of sines, we have law of cosines, we have some work with areas of triangles that we can use. But here's one that was used on an exam at some point. So here's our picture. We have a guy flying a kite. We have an observer. The kite string is 100 feet. The angle from the observer to the kite is 105 degrees. We want to find the distance from the two people. So x is what we are looking for. I need the third angle, which I believe is going to be 35 degrees because the three angles have to add up to 180. And now all we've got to do is use law of sines. So we would say sine 105 divided by 100. Sine 105 degrees divided by 100 is sine 35 divided by x. Then we like to cross multiply to say x times sine 105 is 100 times sine 35. Let's solve for x, divide both sides by sine 105. And I get x is 100 times sine 35 degrees divided by sine 105 degrees. If you had a calculator, you could simplify that, but on our exam, we will not have calculators, so you'd leave it that way. Let's take a look at another question, another triangle one. So we'll make this 6. We'll make this 10, and we'll make this 120 degrees. Let's call that C. When you have an SAS triangle, side included angle side, you need to use law of cosine. So remember how that goes? That's c squared is a squared plus b squared minus 2ab cos c. So we get c squared is 6 squared plus 10 squared minus 2 times 6 times 10 times cosine 120 degrees. C squared is 36 plus 100 minus 120. 120 is in the second quadrant. And cosine is negative in the second quadrant. Reference angle is 60. Cos of 60 is a half. So we get c squared is 36 plus 100 minus plus a half of 120 is 60. So we get c squared is 196. C is the square root of 196, which happens to be 14. So that's how far apart those people would be. All right, I want to take a look at an inverse question. If I give you the following graph, can you construct its inverse? Let's make sure you can see this. So here we go. Here's the graph. So we are given a graph of y equals f of x. This is a graph of y equals f of x. And the goal is to construct an inverse. So I need to find some nice points. There's the point 2, 1. So I see 2, 1 on my graph. X is 2, y is 1. Here is the point 3, 5. Here is the point 0, negative 2. Here's a point, I don't know, negative 5 and negative 2.9 or some kind of thing like that. But if we want to find the inverse, we've got to switch the order. So 2, 1 becomes 1, 2. 1 on x, 2 on y. 3, 5 becomes 5, 3. 5 on x, 3 on y. 0, negative 2 becomes negative 2 on x, 0 on y. Negative 5, negative 2.9 becomes negative 2.9, negative 5. So we can see the asymptote is going this way. And then we're going to go ahead and follow up through these points to get you a version of the graph of y equals f inverse of x. Looks good, I hope. All right, let's look at our most recent stuff. First off, let's take a look at how we plot points. So I've got a polar graph here, and I want to plot some points for that polar graph. So if I say the point P is 3 pi over 3, R is 3, theta is pi over 3, theta is pi over 3, 1, 2, 3, boom. There's the point P. If I want to say Q is negative 2 pi over 4, well, I go to pi over 4, which is here, of course. That's the positive version of pi over 4. Here's the negative version of pi over 4, going backwards. So negative 2, 1, 2 would put me there. So that would be Q. If they're both negative, if I have, let's say, negative 4 and negative pi over 6, well, where is negative pi over 6? Pi over 6 is 30 degrees. Negative pi over 6 is here. So we have 11 pi over 6 or negative pi over 6. But the negative version would be going back the other way. Hard to see this a little bit. So negative 4, negative pi over 6 going back the other way. 1, 2, 3, 4 would be here, and we'll call that point R. So you need to make sure that you can go ahead and graph those things. What I want to finish off with is our cis theta stuff. So I'm going to give you two complex numbers. We will say Z1 is 6 cosine 20 degrees plus I times the sine of 20 degrees. We're going to say Z2 is 3 times the cosine of 70 degrees plus I times the sine of 70 degrees. So you know I like that cis notation just to make it a little simpler for us to work with. So what I'll say is, I'll say this is 6 cis 20 degrees, and this is 3 cis 70 degrees. So the first question I'll ask is, what is Z1 times Z2? So that is 6 cis 20 times 3 cis 70. You multiply the lengths and add the angles. So that's 6 times 3 cis 20 plus 70. So I get 18 cis 90 degrees, which is 18 cos 90 degrees plus I times the sine of 90 degrees. Let's remember, where's 90 degrees? It's here. It's the point 0, 1. The cosine is 0. The sine is 1. So this is 18 times 0 plus I times 1, which is 0 plus 18I, or 18I. But you can't always simplify it quite so easily. If instead I had asked you to do Z2 divided by Z1, Z2 divided by Z1, that would be 3 cis 70 divided by 6 cis 20. So yes, you divide the modulus, you divide the lengths, 3 over 6, and subtract the angles, cis 70 minus 20. So I get 1/2 cis 50 degrees, which I don't know what 50 degrees is. I'm not going to worry about it. But I'll just write my answer this way: 1/2 cos 50 degrees plus I times the sine of 50 degrees. Good enough for us to do that division. All right, I have one last question to do. I was hoping to finish this in an hour, but I'll maybe a little bit over. We're going to give you a complex number. We're going to say Z is -√3 plus 1I. So let's visualize where that is. -√3 plus 1I. It's in quadrant 2. So we have to keep that in mind for our angle theta. Now, you'll remember that r squared is a squared plus b squared, or x squared plus y squared. So r squared is -√3 squared plus 1 squared. R squared is 3 plus 1. R squared is 4. So r is 2. That's all well and good. But what about theta? So we've told you the tangent of theta is b over a, or tangent of theta is y over x. Focus, please. Thank you. So tangent of theta is b over a, or if you like, y over x, if you prefer that notation. So tangent of theta is 1 over -√3. So you can go back to our table. Our reference angle is 30 degrees. So we have 30 degrees as a reference angle, but we are in quadrant 2. So if this is 30 degrees, that would make theta what? Theta is 180 degrees minus 30 degrees, which is 150 degrees. So now what I have is I have Z is r cis theta is 2 cis 150 degrees. What do I want to do with that? Let me ask you to find Z cubed. So that'll be our question. Find Z cubed. If that's our goal, then Z cubed will be 2 cubed cis 150 times 3. So Z cubed is 8 cis 450 degrees. Now, you'll see that's actually kind of nice because 450 minus 360 is 90. So cis 450 is the same as cis 90. So Z cubed is 8 cis 90. We've seen this many times today. What does that mean? That means Z cubed is 8 cos 90 degrees plus I times the sine of 90 degrees. Again, our favorite thing of the day, 90 degrees is here. Cosine is 0, sine is 1. We get z cubed is 8 times 0 plus 1 times I. So my answer is z cubed is 8I. All right, well, you've watched me do problems for an hour and 10 seconds. I hope it helps you remember some of the concepts from earlier in the semester. But my advice is watch it a second time, pause the video when I pose the question, try it yourself, and then see if you get it right. All right. It has been a pleasure working with you this semester, and I wish you the best on your exam tomorrow. And I will see you then. Bye-bye.